Hi, Year 12. So when we are resolving a vector into component parts, it can be quite frustrating to have to draw your right angled triangle, work out which one your hypotenuse, adjacent, opposite is, and go through the whole faff of using Pythagoras. It's a bit frustrating. I don't enjoy doing it, so I want to show you a bit of a cheat for how you might be able to find your angles. Sorry, I'm working in a shed and the sunlight keeps changing because obviously I'm outside. Sorry, so it's going very shady. Right, so I want to talk you through a method that I use that just makes my life a whole lot easier. So first things first, we obviously need to be given an angle. Okay, now I've got two identical vectors here. Let's take these to start with. Now, in a question, they would have to tell you an angle for you to be able to do anything with it. So the only possibility is they could give you this angle, let's call that one theta, or they could give you this angle, let's call it alpha, just so that we're clear on the difference. Okay, now in both cases, I want to split my vector into its horizontal component and its vertical component. Now obviously I could draw my triangle and close my triangle and find my right angle. I'm just doing this by eye to make life a bit quicker. And obviously my right angle would be here. But hopefully you can see that actually I don't even need to draw this line in, because this distance is going to be the same as this distance, and obviously this distance is this distance. So I would just always just refer to this line and this line. But for the sake of getting your head around the angles, let's stick with drawing our right angle triangle to start with. So obviously this is our hypotenuse. Okay, we've got opposite and we've got adjacent. Now this is something that you should be happy with from maths, and if you're not, you're going to need to practice. Okay, now we know that we have our trig identities, SOHCAHTOA, and let's say we want to find firstly the vertical components. We want to find O. Okay, we know the angle theta, and this was our original vector, so we know the hypotenuse. Okay, so we know our hypotenuse and we have an angle, so we're going to use our SOH. Okay, so we know then that O is going to be equal to sine of the angle multiplied by the hypotenuse. So this one is going to be H sine theta. Okay, if I want the adjacent, I have the angle, I have theta, and I also have the hypotenuse, because remember that was my original vector, so I must have that. So in that case I have C, I have H, and I know those. So A must equal H cos theta. Okay, now I'm going to go again, but this time I've got a new right angle triangle. Okay, my right angle this time is going to be here. So again, I have my hypotenuse, which is my original vector. I have my opposite. I have my adjacent. Okay, let's say I want to find my vertical component, so that's A. Okay, so A is going to be cos of the angle, which is alpha, multiplied by the hypotenuse. I'm going to put that at the front to make life easy. Okay, H cos alpha. If I want the horizontal component, O, I'm going to use this one because I have H, because I have the original vector. So I've got H sine alpha. Okay, if I put that here, I can't quite fit this one in here, but hopefully what you'll see is where the sine is has switched. So in our first one, when we had this angle, sine became our vertical, and in this one, when we knew this angle alpha, sine became our horizontal. So we cannot just say to ourselves, oh, if it's a horizontal line, it's cos, and if it's a vertical line, it's sine. It doesn't work like that. It very much depends on which angle you are given. So you cannot just commit to memory cos is horizontal. That's not going to work, okay? Because in this case, horizontal was sine. So completely erase that from your memory if that is something that you thought before, okay? I am going to teach you a trick though to save you having to do all of this, okay? What we do is we take our pen and we align it along the vector that we have. Okay, now, if to get to the thing that I'm trying to find, in this case the horizontal, we've cut through the angle that we are given, it's cos. So if we sweep through the angle, it's going to be cos. You will notice on the second one, the angle we had was this one, alpha. Here's my original vector, I line my pen up. To get to the vertical, I had to sweep through the angle, okay? I had to cut through that angle. And again, that A value uses cos, okay? So it works in both cases. If I sweep through the angle, it's going to be the vector cos of the angle. If I move away from the angle, it's sine. So let's look. Let's start along our original vector h. To get to the vertical component, sorry about the shadows, it's so frustrating to not be able to do this in a classroom. Here's my original vector, I sweep away from the angle that I know, it's sine. Okay, so it's away from is sine. And I'll prove it again over here. So here's my original vector. If I move away from the angle alpha, I get sine. The horizontal was sine. So it proves it in both cases. Okay, so if you sweep through the angle, you take the vector and multiply it by cos of the angle. If you sweep away from it, it's sine. Okay, so let's just do some practice looking here. Okay, so let's imagine that I know this angle theta. And I want to split this vector into its component parts. I'm just going to do it freehand because I'm trying to do this as quickly as possible. And I want to convert or resolve this vector, let's call it h, and I want to find the vertical component of it and the horizontal component of it. So look, here's my original vector. I'm sweeping through the angle. We said that through the angle was cos. So without even drawing my right angle triangle and using Pythagoras, I already know that that's going to be h cos theta. And therefore, this one will be h sine theta. Okay. Come on, camera, stop being blurry. Okay, next one. Let's say this time I know this angle theta. Okay, and then let's call this vector A. And I want to resolve again into my horizontal and my vertical component. Oh, it's a little bit high, but you get the idea. Okay, I start on the vector. I sweep away from the angle I know. Away from is sine. Through is cos. Okay. On this last one, I'm going to illustrate both angles. Okay, so let's say we call this alpha and we call this one theta. Okay, and we're going to resolve this. So we've got the vertical component and we've got the horizontal component. So it's not a very straight line, but you get the idea. Okay, now I am going to call this vector h. I can express the vertical component either in terms of alpha or theta now. Okay. As I go through alpha, through is cos, I can call this h cos alpha, and therefore because I'm going away from alpha this way, I call this sine. But equally, if I start with h and I move away from theta, I can call this h sine theta, or I can call this one h cos theta, because to get from h to my horizontal, I've swept through the angle. These are equivalent. These are equivalent. You can check it on a calculator if you're not sure, but it's just worth remembering this, that if you go through the angle, use cos. If it's away from the angle, it's sine. Now, that will save you a lot of time in exams rather than having to sketch out right angle triangles and using Pythagoras. So hopefully this has been well worth your time.